Okay, so here are some examples of some stereocenters. Here we have 2-butanol. So starting here, I've got 2-butanol, and 2-butanol has a stereocenter that's right here, right, with the wedged OH group. And so it's an sp3 carbon, it's got 4 different groups attached. We can assign this as R or S. So the first thing we need to do is find the 4 groups. We have an OH group here, we have a hydrogen that's pointed back that we haven't drawn, but I'm going to draw so we can see it. Right? And we have the methyl group on this side and we have an ethyl group on this side. So let's assign priority numbers, right? Step 1, priority numbers. And we assign that based on atomic number. So we have an oxygen attached to the carbon, we have a hydrogen attached to the stereocenter, we have a carbon on this side and a carbon on this side. So right away we know that the oxygen is the highest, 1. The hydrogen is the lowest because it's got an atomic number of 1, so that's the 4th priority group. And then we have 2 carbons. We have a CH3 group on this side, we have a CH2 CH3 group on this side. So if the atomic numbers are the same, right, then we move one step out, then move another atom away from the stereocenter. Okay, so I'm going to redraw this here. We have this carbon here that's our stereocenter. It's got whatever, an OH and an H, right? But if we go this way, we've got CH3. If we go this way, we've got CH2, CH3. Okay, so here's our stereocenter here. We look first, we compare this carbon to this carbon, and obviously those 2 carbons have the same atomic number, and so we can't make any distinction between those 2 as far as assigning priority numbers. So if the atomic number is the same, we move 1 atom further away. If we go 1 atom further away from this carbon, we can choose any one of these, but the choice is, obviously hydrogen is the only choice that we have. If we go 1 atom further away from this carbon, there's hydrogens here, but we're going to choose the highest priority thing, and that's the thing with the greatest atomic number, and that's a carbon. So now we're comparing this carbon here to this hydrogen here. And obviously carbon has a higher priority number than hydrogen. So that means that this whole group over here is higher priority than the CH3 group. Right? So that means that this group over here is group 2, and the methyl group is then group 3. Right? Because the methyl group still is higher priority than the hydrogen, because carbon is higher than hydrogen. But it's lower priority than the ethyl group because the ethyl group has an extra carbon in it that gives it a higher priority than that. All right, so we've assigned our priority numbers. We have a 1 on the oxygen, a 2 on the ethyl group, a 3 on the methyl group, and a 4 on the hydrogen. Now we go to step 2, right? Find that 4th group. Is 4th group back? In this case, the answer is yes. And that means that we go 1 to 2 to 3, 1 to 2 to 3, and say if it's clockwise, we have an R stereocenter. If it's counterclockwise, we have S. So in this case, we go 1, 2, 3, right? That is clockwise, and so this one is R. So that's an R stereocenter. So we would call this compound R2-butanol, right? Which differentiates it from S2-butanol. So S2-butanol is its enantiomer. So I've drawn the mirror image over here. So this is the mirror image. So we don't actually have to go through all of this. We know that if we've drawn the enantiomer that this must be S2-butanol, because by definition the enantiomer has the opposite configuration around the stereocenter. But let's go through it because we've got nothing else to do. And it'll also be worthwhile, right? Because it'll help us understand how to do this. So again, the oxygen is going to be the highest priority number. The hydrogen will be the lowest. Hydrogen is always the lowest priority number because nothing has a lower atomic number than 1. We have, again, the ethyl group on one side and the methyl group on the other. The ethyl group will be group 2. The methyl group will be group 3. So we've assigned the priority numbers. And now, of course, notice that the priority numbers are the same as they are on R2-butanol because it's the same 4 groups, and so they're always going to end up in the same order. Go from 1 to 2 to 3 because group 4 is back, right? So we can just jump straight into the arrow. And we notice that, of course, this goes counterclockwise. And therefore, this is S2-butanol. Okay? So assigning priority numbers, watch that 4th group. If the 4th group is back, you're set, and then you can do it from there. All right. So that's if we draw the mirror image. If we switch the stereo center, right? If we just switch from wedge to dash, we claimed in the previous in a previous video that this also makes the enantiomer. So this, if that works, this should also be S2-butanol. And in fact, if we assign the priority numbers, we find that that's true. So 1, 2, 3, and then 4 is the hydrogen. The 4th group is not pointed back, right? So then we have to switch group 4 and the group pointed back. Right, so we're going to do that. So we switch group 4 and the group pointed back, and so that's the OH group in this case. And we end up with OH coming out, hydrogen going back, 4, 1, 2, 3. We go 1, 2 to 3. That's clockwise, so this one is R. We know that we just made the enantiomer, so this one has to be S. And so once again, right, it holds up that drawing the enantiomer, either way that we draw it, if we draw the mirror image or if we switch wedges and dashes, we get the opposite enantiomer, the S2-butanol, if we start from the R2-butanol. Okay. Common mistakes, right? Remember that you're only going 1 to 2 to 3 to determine clockwise or counterclockwise. Oftentimes people will try to include the 4th group in that. The 4th group we just point away from us and then we don't worry about it anymore, right? So only draw your arrow from 1, 2 to 3 and then stop. Don't worry about where the 4th group is, right? 1, 2, 3, doesn't matter where the 4th group is. 1, 2, 3, doesn't matter where the 4th group is, right? Don't try to include that in there. It can get confusing if you try to make your arrow even longer than that. Just 1 to 2 to 3, even 1 to 2 is actually enough to kind of tell you if you're going clockwise or counterclockwise, right? The only thing is you definitely don't want to go, like you can, I guess, technically go 1, 2 this way, but you want to go 1, 2, 3 because you want to follow through all the way. So only use 1, 2, 3 to determine clockwise or counterclockwise. And then the other issue is remembering when you switch. So if you switch to put the 4th group back, then you're finding the orientation of the enantiomer, which is R in this case. And that means that your original structure will be the opposite. So your original structure will be S. So those are the common mistakes. Common mistakes is use 1, 2, 3. Where's my, there it is, but not 4, right? The other thing, well, I guess this is the correct way to do it. So I shouldn't call this common mistakes, should I? I'm going to call this things to remember. Right? Remember to go 1, 2, 3. Remember not to use the 4th group for that, for clockwise and counterclockwise. The other thing is remember when to switch. Right? It would be great if every stereo center was always drawn with the 4th group pointed back like this. Unfortunately, that's not the case. And so you will have to sometimes switch, figure out the orientation of the enantiomer, and then switch back. Here's a couple of slightly more tricky versions of the assign R and S question. So definitely pause the video, take a moment, assign priority numbers, figure out what you think these things are, and then we'll do it, and I'll talk about what makes these work. Okay, so I'll stop talking for a little bit so you can pause. And welcome back. All right, so as you've no doubt figured out, right, there's a hydrogen that's hiding at each of these stereocenters. So there's a hydrogen there, and there's a hydrogen here. And so once again, we have our fourth group. It's pretty easy to find because hydrogen is always group 4, right? 4. In this case, we have an oxygen, a carbon, and a carbon attached, so the oxygen gets the highest priority. And then we look at, okay, so now we have a carbon and a carbon. In order to figure out which of these gets higher priority, we have to go one more space away from the stereocenter, right? So the next space is a carbon and 2 hydrogens that are attached to this carbon. In this case, we have 2 carbons and 1 hydrogen, right? And so because you have that extra carbon, this carbon is higher priority than these hydrogens. So this group, the isopropyl group in this case, ends up being group 2, and this is group 3. Right now, you might say, wait a second, there's an oxygen out here. That's higher priority than anything else. But the key here is that we only move out one step at a time. And as soon as you see a difference between these two groups, that difference decides it. So even though the oxygen is maybe a higher priority or a higher atomic number than carbon, we're starting at this stereocenter and we're moving out. So at this stereocenter, step 1, we have carbon and carbon. That's the same. So we go another step out. Step 2, we have carbon, hydrogen, hydrogen. And over here we have carbon, carbon, and hydrogen. This extra carbon makes this the higher priority group. We never make it all the way out to the oxygen, right? Similar idea over here. The bromine is 1, and then we go carbon and carbon. So that's the same. Each of these has 2 hydrogens attached to it and another carbon, so that's the same. Each of these has 2 hydrogens and another carbon attached to it, so going one more step out, we're still the same. And then from there, this carbon has an oxygen while this carbon just has another carbon. So now if we compare this oxygen to this carbon, this group ends up, this whole group over here ends up with the higher priority. So this is 2, this whole group is 3. Okay, so again, same idea. If you have a higher atomic number group in your or a higher atomic number element in your group, that doesn't necessarily always mean that it will be the higher priority group, because sometimes you'll get to a difference that occurs before we get that far out, right? So this one, there's 3 carbons and an oxygen. On this side, there's 4 carbons, and so the 4th atom in this chain is an oxygen, the 4th atom in this chain is a carbon. That gives this one higher priority. Okay, so now we assign R and S. We have the 4th group back on this side, so that's easy. So now we go from 1 to 2 to 3, right? This is our arrow, and that is counterclockwise, so this one would be S. So you can go through and do the rest of the name on that one if you want, but the stereocenter is S. On this side, our hydrogen is forward, so we need to switch that. So we would redraw this with the bromine up as 1, 1, 2, 3 OH as 2, 1, 2, 3, 4 bromine as group 3, and then we go 1 to 2 to 3. This one is going counterclockwise, so the enantiomer is S, so this one is R, right? So hopefully I didn't go through that too quick, but in this case, right, we switched the wedge and the dash to put the 4th group going back. I guess I didn't draw that in, which I should have, right? So now our 4th group is going back. So now we do the arrow from 1 to 2 to 3. That makes it counterclockwise, makes it S. But since we switched it, that means that our original compound was the opposite, so our original compound is R. Okay. That took a little bit longer than I thought. This is a little bit of a long video, but those are some examples. There is a worksheet where you are asked to just do R and S assignments on a whole bunch of different compounds. So try that out, see how it works. Remember always that you're just switching groups to put the groups back versus forward if the 4th group is not already back. So good luck. Let me know if you have questions, and I'm sure we will talk about this again next week.